Hello students, today we are going to start the topic polynomial, which is your chapter number 2 of NCERT. And on this topic today we are going to discuss a few of the topics which are written in front of you. The types of polynomial, degree and coefficients of the polynomial, the graphical representation, zeros of the polynomial and the relation between coefficients and zeros. So to begin with this topic, first of all, I would like to introduce you with the name of the chapter polynomial, what actually a polynomial means. So polynomial basically is an algebraic expression in which the power of the algebraic expression or the power of the variable in the algebraic expression must be a whole number. For an example, we have a number 4x plus 5. Let's suppose 3x square plus 2x, 3t plus 1, 4 root t plus t, t plus 1 upon t. We are taking few of the examples and we will discuss that which of the algebraic expression is a polynomial and which are not. So in this, if we see that the power of the variable is 1, right? So this is a polynomial because 1 is a whole number. This is a polynomial. Now next one is 3x square plus 2x. This is again a polynomial. Why? Because the power of the variable x is 2 here and 1 here. So this is again a polynomial. In the third one, we have a variable t whose power is 1. So this is again a polynomial. But in the fourth case, if we see the power of the t is half. And here the power of the t is 1. But one of the variable present here in this algebraic expression is a power half, which is not a whole number. So that is why this is not a polynomial. The fifth case, the last one, this has a power 1, but the next term 1 upon t has the power minus 1, which is not a whole number. So this is not the case of the polynomial. This is the basic one. So this is how we identify a number, an algebraic expression is polynomial or not. Now, how many types of polynomials we have? So for understanding the types of polynomial, first of all we will study the degree of polynomial. What actually the degree of the polynomial means. Because polynomial is classified into two ways. One on the basis of degree and the other on the basis of number of terms. Right. So first of all we will understand what actually a degree means in the algebraic expression of the polynomial. It is the highest power. Highest power of variable in algebraic expression. Let's suppose I am taking an example, 4x cube plus 3x plus 1. The highest power of x is 3, hence the degree is equals to 3. So this is your degree. If we talk about the coefficient, the mathematical number which is in the multiplication of the particular variable is called the coefficient of that variable. For an example, the coefficient of x cube is 4, the coefficient of x is 3 and 1 is your constant term. The term which does not contain any variable is called as constant term. For an example, we take one more example like 4x cube minus 3x plus 1. Here the coefficient of x is minus 3. So don't get confused. We are supposed to use this negative sign also. So this is your degree. Now we will move on to the types of polynomial. We know about the degree, so we can actually discuss the types of polynomial. Now the polynomial has two flavors. First, on the basis of degree, and second is on the basis of number of terms, right? On the basis of degree, let's suppose if the degree is 1, we call it a linear polynomial. If the degree is 2, we call it a quadratic polynomial. If the degree is 3, we call it a cubic polynomial, and so on. If the degree is 4, we will call it the polynomial with degree 4. and on the basis of number of terms, if the number of term is 1, we call it as monomial. If the number of term is 2, we call it binomial. If the number of term is 3, we call it trinomial, and so on. So this is the classification of the polynomial on the basis of degree and on the basis of number of terms. Now we can move on to the graphical representation of the polynomial and the zeros, right? So we have to understand two kind of graphs. The first is the straight line one. This is for linear polynomial, and the other one will be your parabola kind. This is for the quadratic one, right? And these are the two most important graphical ones, and the rest of them are not actually very important, so we will skip them. So the linear graph, the linear polynomial is always contains a straight line, and the quadratic one will always contain a parabola kind of a graph, right? Now the important thing, which is actually the first exercise of your chapter polynomial, that is 2.1, is what is the graphical representation of the zeros. So let's suppose we have a polynomial px. Now here p is the representation of for the polynomial, and p of x means the polynomial has a variable x in it. So let's suppose we are considering example 4x plus 1. We have any of the graph, let's suppose. So if we put x0, we get y1, right? If we put x2, we get y6. So we will get this kind of a graph. This is for the example. I'm not making the actual graph, but this is I'm taking as an example. So we are supposed to understand that if this is the equation, right? If this is the graph of that polynomial, given polynomial, we need to find out the number of zeros available in this, right? So we can say by seeing that at how many points the graph is touching the x-axis. So here there is only one point where the graph is touching the x-axis. That means the number of zeros is equals to 1. This was the example when the polynomial was given. It could be the question that your polynomial is not given, but it was said that you have a polynomial px and its graph is given like this, and you are supposed to tell how many number of zeros are present actually. So you are supposed to see that at how many points the graph is cutting the x-axis. So we are getting 4 points, right? So we will say that the number of zeros are 4. But in the same question, if it was given that find out the number of zeros for the polynomial p of y, right? So we have to see that at how many points the graph is cutting the y-axis. Now at the y-axis the graph is cutting only at 1 point, so number of zeros will be 1 here, right? So this is a graphical representation of the zeros and the polynomial. Now we will move on to the next topic, which is the zeros of the polynomial. What actually are the zeros of the polynomial? So in this particular chapter polynomial in class 10th, we broadly will discuss the quadratic polynomials and the cubic ones, right? We will not study the linear ones as they were easy and we have already studied in the class 9. So we will take an example of a quadratic polynomial. The quadratic polynomial's general form is always will look like this, where a is your coefficient of x square, b is your coefficient of x, and c is the constant term, right? Then the zeros. What are zeros actually? Zeros of polynomial is that value of variable for which the value of polynomial becomes 0. What do you mean by the value of the polynomial becomes 0? Let's suppose we have an example of 4x plus 1, right? This is an example. Do you have any method to form this 0? Yes, we have. if we put x is equals to minus 1 by 4, right, you can pause the video and can put the value. You will always get the value of this as 0. How? You will put the value 4 minus 1 by 4 plus 1. 4 will cancel out, minus plus 1 will be 0. So this is the thing, that here x is equals to minus 1 by 4 is that value for which the polynomial 4x plus 1 is becoming 0. So x is equals to minus 1 by 4 will be called as the 0 of the polynomial, right? Now here the concept comes that the number of zeros is also dependent on the degree, right? If the polynomial has degree 1, the number of zeros will be 1. If the degree is 2, the number of zeros will be 2. If the degree is 3, the number of zeros is 3. So if we are talking about quadratic polynomial, we will always get 2 zeros, and we are calling them as alpha and beta. These are the just names of it. You can also call them a and b or p and q, but the mathematicians have given alpha and beta, so we actually will use, because this is universally used things, so we are using alpha and beta, right? You will be used to of these two terms, alpha and beta. These are the terms which actually is coming first time in this class, so you will be new for them, but you will be get used to of it. So alpha and beta are the names of the two zeros. It's not necessary that the first zero which is coming must be the alpha, or the second one must be the beta. You can call any of the zero alpha and any of them as beta, right? Okay. Now how we find the zeros of the quadratic polynomial? So this is actually a basic concept which you have already studied in earlier classes, maybe in class 8th or 9th. That if we have a quadratic equation and we need to find out the zeros, we do middle term splitting, right? The middle term splitting is the method which we use to find out the zeros, right? So here if we want to do it, this will be x square minus 4x plus 2x minus 8. We take x common from here, so this is x minus 4. We take 2 common from here, this is x minus 4, and then we will take x minus 4 common, it will be x plus 2. These are the factors, okay? This is actually not the zeros of the polynomial, this is the factor of this. If we want the zeros, we are supposed to put them, we are supposed to equate them with the zero, so that we will get the value of x from it, right? So these are the zeros of the polynomial. Now if we need to set the relation between the zeros and the coefficient, first of all we need to understand what actually by the relation mean. Relation means here that if we have alpha and beta as the zeros, right, of the polynomial ax square plus bx plus c, then sum of zeros, that is alpha plus beta, will be equal to minus b by a. Now what is minus b? B is the coefficient of x and a is the coefficient of x square, and the product of zeros, that is alpha into beta, will be equal to c by a. Now c is your constant term and a is again the coefficient of x square, right? So now we will try to figure it out, how it works. So we already have an example. We have an algebraic expression or the polynomial, we would say, and the zeros. So we try to verify them, right? So first of all we will find out the sum of zeros, that is 4 plus of minus 2, and it's coming out to be 2. Now we will find minus b by a from this equation. What was b? Minus 2. What is a? 1. So this is again 2. So we can see that alpha plus beta, that is this, and minus b by a, that is this, are coming out to be equal. So we can say alpha and beta is equals to minus b by a. Now we will check for the product. So product of zeros will be 4 into minus 2, that is minus 8, and now we will check for the c by a. So c here is minus 8 upon 1, so it is again minus 8. As these two are equal, we can say alpha into beta is equals to c by a, hence verified. So this is how we do it. So first we need to understand two of the things. First we need to understand the middle term splitting, okay, that we need to practice, and then setting the relation, okay, for the particular question. We can take one more example to solve it. If you want to copy it, you can pause the video and can note down the question. We'll moving on to the next question. Okay, so which question you should take? Okay, we can take the question t square, that is the question number 5th. T square minus 15, right? We need to find out the zeros of it. So we'll apply the algebraic identity a square minus b square, which is a minus b and a plus b. We can write t as t square minus root 15 square. So this will be t minus root 15, t plus root 15, and if we want the zeros, we have to equate them to 0, so that we will get the value root 15, t plus root 15 is equals to 0, so t will be equal to minus root 15. Okay. Now we need to understand one of the thing here. In this equation, we do not have any of the linear term, right? That is our t raised to the power 1 term we don't have. So if we want to write it in the general form, we will write it like this. Okay, this is the coefficient of t was 0, and that's how it became 0, and that's why it's not here in the equation. So we consider that the coefficient of the t is 0, right? So we can convert this into the general form, and then we can do this. Now we need to find out the sum of the zeros, that is alpha plus beta, okay, root 15 plus minus root 15, and eventually it will be 0. And we need to find out the b by a term, so minus b minus of 0 upon a is your 1 will be 0. So we can say that alpha plus beta is equals to minus b by a, and for alpha into beta, if we check, root 15 minus root 15 will be minus 15. And as we know that the alpha into beta is equals to c by a, so we will check for the c by a also. It is minus 15. These two are equal, so we can say alpha into beta is equals to c by a, hence verify, right? Okay, so this was your question. Now we are moving on to the next thing, which is what if the sum of zeros and product of zeros is given, and we need to find the polynomial. So we'll do this with the two cases. We have case 1 and case 2. We have two methods of doing this question. For the case 1, we are taking one of the example. Okay, we will take the example root 2 and 1 by 3. Okay. So for the case 1, we have a direct formula, x square minus alpha plus beta x plus alpha into beta is equal to 0. We just need to put the value. Okay, it's in the question given that this is your sum of the zeros and this is your product of zeros, right? So we just need to put the values. What is alpha plus beta? Root 2 x plus alpha into beta is 1 upon 3 is equal to 0. Now we cannot leave it here, so we take the LCM. So 3 will be your LCM. 3x square minus 3 root 2x plus 1 is equal to 0. Now this 3 will go to the 0 and will become 0. So the final equation will be 3x square minus 3 root 2x plus 1 is equal to 0. This is your case 1. You can note down this so that you can continue with the case 2. Okay. Now the similar question with the case 2, right? Alpha plus beta is given as root 2 and alpha into beta is given as 1 upon 3. Okay. As we know that the alpha plus beta is b upon a, so we can write it like this, and alpha into beta is c upon a, we can write it like this. In this method, what we are supposed to do is we have to make the a same on the both of the sides, minus b by a and c by a. So what we will do here, we will multiply this by 3. If they are same, we directly will compare the coefficients, but here we have to make the a same, so that's why we are multiplying the denominator and numerator both by 3. So this is minus b by a will be 3 root 2 upon 3, and your c by a will be 1 upon 3. Now what is your general form? Ax square plus bx plus c, right? Now see, we have a3 on the both of the sides, so we can directly compare and can write that the value of a will be 3. See, minus b is 3 root 2, so b will be minus 3 root 2 and c will be 1. If we are supposed to put the value here, so 3x square minus 3 root 2x plus 1. This is your case 2. So this is how you are supposed to do your first and the second exercise of the polynomial. In the next lecture we will be doing the division of the polynomial, and the chapter will get over. Also we need to do one more topic which is given in the optional exercise, which is for the cubic polynomial. If the 3 of the zeros are given, then how we set the relation between the 3 zeros and the coefficient. So that we will do in the next lecture. Thank you so much.